Welcome to Revolution Against Evolution. I'm your host, Doug Sharp.
Your co-host Rich Gear here as well. And Doug, we have a special guest tonight, don't we?
Yes,
Uh,
this is Brian Lauer.
yes.
He is a researcher. We're going to let him introduce his credentials himself. We thank you for joining us. We're going to talk
Thank
a
you,
little
Doug.
bit about the scientific support for the hydroplate theory.
Yeah, well, thanks a lot, Doug and Rich. Yeah, it's a pleasure to be able to talk about a theory, another flood model. And my perspective is if you want to think, you need to see both models. Otherwise, you just memorize. And I talk a lot at St. Cloud State. I go and talk to the students. And I just pretty much go wherever God opens the door. I've got a YouTube channel called Solidify Your Faith. And I think that the hydroplate theory is one of the strongest. What did Mike Wells or Bill Wells say? He was a jet fighter pilot, and he had full confidence in his offensive and defensive weapons. And he says that the hydroplate theory is a very, very good weapon for the creation battle. And he says that we need to be better equipped to go into the battle.
Yeah, we might get into the comparison of the different models that are out there. I would like you to explain to us the scientific evidence for the hydroplate theory, as well as some of the objections that people who have a different theory might have, and how we would explain away those objections. So if you can do that for us, we'd appreciate it.
Yeah. Yeah. Well, the hydroplate theory, it has the answers, but if we don't know what the questions are, then the answers really don't mean anything. And if you want, I can share some slides with a bunch of questions that the secular scientists don't have answers to. Let's see. We're gonna try and share this.
Okay.
Let's see. Let me know if you can see this.
I see it.
Okay.
You see it?
Yeah. Yeah, these are screenshots from secular journals and articles, and it's unexpected. Researchers want to know why. Fossil oddity, long-standing puzzle. I totally didn't believe it. It shouldn't exist. Scientists puzzled. Double-ended mystery. Surprising features. Unanswered questions. Hard to believe. World of surprises. Major mystery. Wrong direction. Puzzle scientists. And yet, if there's one theory that could answer all these puzzling questions and clear it up, I think that it would be worth looking at. But here's some of the questions that they have. This is from Science Daily. Where did the Earth's crust go? It says the Earth's crust is missing in the mid-Atlantic. The mantle is exposed to the seafloor. Was the crust never there? Was it once there but then torn away? If so, then how and why? And the hydroplate theory clearly shows that. What caused the ice age? And once it started, why did it stop? This is from Nature. They say perhaps the longest standing puzzle in Earth sciences is what caused the Northern Hemisphere ice sheets to come and go. And the secularists, they have a hard time with that one, but the creationists, we can answer that. And then scientists probes fossil oddity, giant redwoods near the North Pole. How do redwoods grow where it's dark 4 months of the year? That doesn't make sense. And these fossils are chemically preserved at a level you would usually expect to see in something that's only 1,000 years old. And it's supposed to be 45 million. So the evolutionists are having a hard time with this. This is from Discover, the 11 greatest unanswered questions in physics. How are the heavy elements from iron to uranium made? And that's the new chapter in the ninth edition. They've got the origin of radioactivity. And this is from, let's see, Science. In 2002, it says we're all made of star stuff. The Big Bang created hydrogen, helium, and a little bit of lithium and other light atoms. But everything else, the carbon, oxygen, and almost 100 other elements that make up animals, plants, and Earth itself, was made by stars. The problem is that physicists aren't quite sure how stars did it. So they're puzzled, but yet the hydroplate theory can do that. And then from NASA, we want to ask you, what causes mountains to rise? What's the mechanism, energy, and forces? How did marine fossils get up there? Because the marine fossils up there in the presence of limestone and ocean marine fossils at the top of the mountains is one of the key pieces of evidence cited that advanced the idea of plate tectonics. So marine fossils on Mount Everest, that's what they think is, validates plate tectonics. And I would object to that. Okay, how do plateaus form? And this says the problem of uplift in the large plateau areas is one which has puzzled students of the Earth's crust for a long time. What mechanism would cause a large volume of low-standing continents to rise rapidly a mile in the air? And then down at the bottom, it says we have a double-ended mystery. For if the Colorado Plateau seemed to have grown downward at the same time that it emerged, part rose upward. And then how did the Mariana Trench form? 6.8 miles below the sea. And why are the trenches mainly in the Pacific? And why is the Pacific so much different than the other oceans? Why does it have 40,000 volcanoes, that sea mounts and table mounts? And then how did the mid-oceanic ridge form? This is a 46,000 mile mountain range that goes through the bottom of all the oceans and comes together like a seam on the baseball. How does that form? And it's got tension cracks in it, not compression, tension. These are straight. Like when you're pulling a rock apart, it'll break at the weakest point, and then it'll be straight. You got tension cracks in two directions, vertically and horizontally. How does that happen? And then and why are the mountain ranges parallel to the Mid-Atlantic Ridge? And let's see the inland seas. What formed them? The Mediterranean and the Gulf of Mexico. They've got a whole bunch of salt down there. The Gulf of Mexico has these huge salt zones. How did that form? And we'll go through that. How did the 90 East Ridge form? This is 3,100 miles long by 120 miles wide, and it's almost perfectly straight, pointing almost straight north, and it points at the Himalayas. And then where'd all the sediment come from that averages a mile deep on the continents? And what caused it to be so evenly mixed with a cementing agent like calcium carbonate and quartz? You can have a whole bunch of sand on your driveway, but it's not turning into cement unless it's mixed with a cementing agent. And yet we've got all these sedimentary rocks all over the world. It had to be evenly mixed with the cementing agent. Where did that cementing agent come from? And what lays down layers of sediment continent wide? And not only is it continent wide, Tim Clary did some research and he shows that it's worldwide layers of sedimentary rock. And you can't get that with local floods. And this is what Answers in Genesis says about evidence for the worldwide flood. It says these same chalk beds can be traced across France, the Netherlands, Germany, Poland, southern Scandinavia, and other parts of Europe to Turkey, and then to Israel and Egypt as far as Kazakhstan. Remarkably, the same chalk beds with the same fossils and the same distinctive strata layers above and below them are also found in the Midwest, from Nebraska to Texas, and from Alabama to Arkansas to Colorado, and they also appear in Australia. And then how do flat layers form on top of slanted layers in the Grand Canyon? And again, the hydroplate theory will explain all of this. Why did the Colorado River run through the plateau instead of around it? I debated a paleontologist on the origin of Grand Canyon, and I think Walt Brown has his theory. I think it's undefeatable. I mean, it answers all the questions. Where'd all the limestone come from? Because to make limestone, it produces carbon dioxide. And there's 60,000 times more carbon dioxide on Earth than in the atmosphere. So how do you get all that to form without all the carbon dioxide in the atmosphere? And then how does this 5 to 10 ton block get lifted up into sedimentary rock? And if you notice that the rocks there, it's kind of curved around it. It was lifted up there when it was still sediment. And it was lifted up. I don't know how many feet that is, but you see that arrow. It got formed in that rock layer, and it got lifted up to another layer. And that's at Isis Temple in the Grand Canyon. What force crushes granite? These are compression cracks. They're squished together they're like marble canyon, like marble cake. And this stuff is 50 miles long, that canyon. So how do you crush granite with that much force? And you see the same thing in the Vishnu schist at the basement rock of the Grand Canyon. Then how do mesas, buttes, and spires form? How do petrified trees form? How do submarine canyons form at the base, at the end of most rivers like the Congo and the Ganges and the Hudson? There's these submarine canyons, and those can't form under the water. So how did that happen? You got a huge canyon in Greenland underneath 2 kilometers of ice, and it was cut by a river, not by a glacier. How does that happen? You got liquid lakes underneath 2 miles of ice down in Antarctica, and that's a tough one to explain. And the South Pole is mostly covered by ice, but fossils show that crocodiles, dinosaurs, and palm trees once lived there. Well, how can palm trees live there when it's dark a lot of the year? And then on the other side, in the Arctic Circle, they find stuff like snakes, tortoises, alligators, badgers, shrews. They can't grow in permafrost, can't live there. Then you got the redwood trees up there. They can't grow in permafrost. And then you got mammoths all over up there, frozen ones. And they are not Arctic animals. They don't have wool like it says. They have hair. And they eat too much. They drink too much. There's no way they can live up there. And one of them was actually frozen standing up. And it's in the museum in St. Petersburg, I believe, in Russia. And so how did it get so cold so fast during late summer to freeze it? And then why didn't it thaw out? And then why were there no glaciers in parts of Alaska? It's really hard to get a map of the glaciers. And when I saw this, it's like, wow, you know, up in Alaska, there wasn't a glacier during the Ice Age. The same thing with Siberia. Siberia didn't have an ice age. That's pretty odd. And then the moon is rusting, and researchers want to know why. While the moon is airless, it's got hematite, a form of rust that normally requires oxygen and water. So that has scientists puzzled. And it's very puzzling. The moon is a terrible environment for hematite to form. Totally didn't believe it. It shouldn't exist based on the conditions present on the moon. And then why is the near side of the moon so much different than the far side? The dark area up there, those are the lava flows, and that's from impacts, I would say. And the near side is more pounded than the far side, which is counterintuitive because the Earth protects the near side. And especially if you throw in the gravity, it's going to be a lot of that stuff's going to get sucked into the Earth, not the moon. And yet the near side of the moon is the one that's pounded. And then the Earth's, according to NASA, the Earth's oldest rock was found on the moon. How does that happen? Of course, they took this page down once I pointed out that the curriculum was wrong. But it says that the rock crystallized about 20 kilometers beneath the Earth's surface. And that's perfect for the hydroplate theory. We'll get to that. They took down that page, but you can see that this is the link that it goes to now. It doesn't go to the one that it used to, but other places have it. Ancient earth rock found on the moon, formed in a water-rich environment at temperatures and pressures corresponding to either 19 kilometers beneath the surface or 170 kilometers beneath the on the moon. Then why do comets have stuff from Earth? And this is, I think, one of the strongest points for the hydroplate theory because it was predicted what they would find. And Kevin Lee accurately predicted what NASA would find in comets and asteroids. They find water, salts, silicates, limestone, clays, cubonite. That's a fun one. It's formed in scalding hot water, olivine, organic and amino acids, and bacteria and cellulose. All that stuff's on Earth. And the hydroplate says it got shot up there. And then cubonite, it only forms in scalding hot water. And liquid water can't reach those extreme temps in the comet's low pressure environments. So that's a hard one for the blind chancers. And this is what Pastor Lee has to say about that.
Because I had become a student of the hydroplate theory, I felt fully confident to communicate with Dr. Brownlee and to predict that what he would find was not what he was anticipating. I'm quoting now from his article, A Mission with Many Scientific Surprises. One of the most unexpected was the 2009 discovery of the amino acid glycine. Now, glycine is an amino acid used by all life. How could the amino acids have been formed in the vacuum and near absolute zero temperature of space? He was shocked by this discovery. The finding that inner solar system materials formed at very high temperature were transported all the way to the edge of the solar system to the region where Pluto is one of the major scientific findings of stardust. But Dr. Brownlee can't explain how, but the hydroplate theory can say.
Yeah, and you can see that clip on YouTube, TCCSA, under highlights. Why is there sea plankton found in the outer surface of the International Space Station? And again, Pastor Lee is very confident in the hydroplate theory, and the discoveries are validating it. And then a comet close-up reveals a world of surprises, but not if you go along with the hydroplate. It all makes sense. They find it hard to believe that the present time, that 67P, that's the comet 67P, was originally homogeneous. Comet-forming regions of the solar system were more turbulent and chemically diverse than theories have thought. So their theories are wrong. And on comets, one of the most surprising features discovered by Osiris, but they're rounded boulders, dinosaur eggs. And here's another discovery. This is from Bennu. And it's interesting. I encourage you to watch the guy on the bottom right as this gets explained.
Let me know what you think.
This is the most insane space news in a really long time. This asteroid called Bennu is 63 million kilometers away. That's 160 times farther than the moon is. Over the last few years, this spacecraft called OSIRIS-REx traveled all the way there, touched its surface, grabbed a sample, and brought it all the way back to Earth. And what they found in that sample is insane. It's rich in carbon, nitrogen, and organic compounds, all of which are essential to life as we know it, but we've seen that before. The asteroid is also covered in a mineral called serpentine, which looks like this. And these samples look just like the type of rock that we find here in mid-ocean ridges. This is where the stuff from the mantle of the Earth comes up and touches the water. It's underwater. Scientists think that this asteroid could be a chunk of an ancient small ocean world. This could be a piece of an old watery planet that's been traveling through space for billions of years, and we just took a sample of it.
Wow.
What do you think of that?
Wow. Oh my goodness.
We have a few minor tweaks for, first of all, that watery planet, let's call it Earth,
Oh,
as
yeah.
Kevin Lee likes to say. I wanted to get your reaction, Brian, because when I saw that, I'm like, wow, she works for Walt Brown and Real Science Radio and creating a short for us without us having to do all that production effort.
Yeah, she get the raise, I think. Man.
Well, what everyone just saw on display was an example of a victim of the government schools, a victim of the deceptions and the errors that Brian has uncovered. That girl, to not even consider that this giant water planet is Earth, but that it's been traveling through space for millions of years, is because she has been victimized by exactly what Brian's been uncovering. And it's actually sad. It's sad to see, but it is instructive as to the work we have to do.
Yeah. And so you notice that orange there, that's where that serpentine came from. That's when the mantle touches the water. That's exactly what the hydroplate theory says when the fountains of the Great Deep broke up. And then the major mystery, how two objects each the size of skyscrapers could collide without blowing each other to smithereens, especially puzzling in a region of the solar system where gravitational forces would normally involve collision speeds of 4,500 miles an hour. They can't explain these peanut-shaped asteroids. And yet distant asteroid reveals to be a complex mini geological world, and it says that it's still a mystery. The formation of this system made of a dual primary and a small moon is still a mystery. That's because they've got a blind chance perspective of the past. They didn't think that asteroids could even get moons in the past, and now we keep finding them with moons, so now it's common. But let's have Pastor Lee again explain this about the moons.
The strange moon of the asteroid Dinkinish. When the Lucy probe was here looking at Dinkinish, it saw this. Oh, another asteroid with a moon. And then it went a little bit further and took another angle at it. And it said, oh, it's an asteroid with a moon that is made up of two components that are contact binaries of the same size. Absolutely impossible, except for the hydroplate theory. Principal investigator for Lucy said in a statement, I would have never expected a system that looks like this. In particular, I don't understand why the two components of the satellite have similar sizes. This is going to be fun for the scientific community to figure out. No, it's not going to be fun. They're never going to figure it out unless they embrace the hydroplate theory premise of how they were sent up into space. Contact binary systems seem to be fairly common. Now there's, this is common to find contact binaries, which was impossible to them a few years ago until they keep finding them everywhere. But scientists hadn't seen one orbiting an asteroid prior to Dinkinish, and we never suspected anything so bizarre. Details of how this unusual moon formed remain mysterious, and it will remain mysterious until people embrace Dr. Brown's hydroplate theory. They'll never figure it out. Scientists were shocked in 1993 when for the first time they saw a moon orbiting an asteroid called Dactyl. They said it was impossible, and then they saw it. Galileo scientists correctly stated that it is virtually impossible, that the moon is a captured object, something created completely separately from light. It is impossible to catch a moon in the vacuum of space. Now, decades later, scientists have found at 17%. More than 245 asteroids have orbiting, and now a moon with the moon can only be explained by the hydroplate theory.
Yeah, again, that's at TCCSA. And again, yeah, the hydroplate theory, I think when it gets into the mainstream, it's going to destroy the Big Bang because it's making accurate predictions and they can't explain their findings with that blind chance perspective. And then this is from space.com. What's up with Naiku? Objects, weird orbit, puzzles scientists because it's orbiting in the wrong direction. And how do chondrules get in space? Chondrules were formed in high temperatures, and they were high energy events such as high velocity collisions and splashed about droplets quickly and then cooled quickly and crystallized. That's exactly like the hydroplate says. And we'll just kind of spin through this. Why do the short-term period comets, how come they're 93% prograde, going in the same direction as the Earth, and only 7% retrograde? If they all came from the Oort cloud, it should be a 50-50 mix. But we'll just kind of skip through that. So we've looked at a lot of these oddities, a lot of these mysteries that the secular scientists have a hard time dealing with, and yet we can answer it all with the hydroplate theory. And real quickly, I know Pastor Lee, he did a pretty good job of explaining it last time, but it's by Dr. Walt Brown, Army Ranger, paratrooper, got his PhD from MIT in mechanical engineering, ran the Benet military law lab. And I gave the book to a professor at St. Cloud State because I said, you don't have a theory for Grand Canyon. You want to see a theory that works? And she said, yeah. And to her credit, she went through it. And she said the science works if the assumption is true. She just didn't believe the assumption was true. This is several years ago. And then just a couple of years ago, I gave a book to another professor there, and she had it for 2 days and gave it back and says, Walt's not a geologist. So she didn't care what he said, even though he's making accurate predictions. And that's what I think we need to change is we need to start looking at theories that make predictions. Now, do you want me to go through the hydroplate or do you have questions? I can maybe stop sharing and just give you the bird's eye view of it. Okay, can you see that? Okay.
Yeah, go ahead. Yeah.
Okay,
Yeah,
I will
ahead. I
just
think that would be good for our audience to see that and go get a review of it,
yeah.
find out what we're talking about. Because I
Yeah.
remember reading Walt Brown's book years ago, and I always wondered why he got marginalized because I was very enamored of the book. I thought it explained everything. And I
Yeah.
said to our guest last week, I said, a great scientific theory is one that has explanatory power, according to this is his book. Makes predictions that come true, and is
Yeah.
parsimonious in their ad hoc explanations. In other words, it doesn't have to add a bunch of things to
Right.
prop it up. And
Right.
I felt that he did all three things. And then for years, I really heard nothing. Now we had you, and we had our guest last week. This is awesome, guys. I'm fascinated
Right.
about this. So
Yeah.
yes, go
Yeah.
ahead and explain it. Yes.
Okay, the hydroplate theory, it's just got one assumption, and that's half of the ocean was inside the Earth at one time. In the 8th edition, it said it was 10 miles deep, and now it's 60 miles deep. And so just think of the Earth as a big apple, and the crust is made of granite, and it's up to 60 miles thick. And then underneath that, there's a layer of water about a mile thick, and underneath that is the mantle. That's the one assumption. And if you grant that assumption, then everything else flows. But now you add the laws of physics, and that's would be the moon. You got the Earth, and you got the Earth here, and the moon. The moon is going to tug on the Earth, so it's going to stretch and compress the crust. The moon tugs on you get high tide and low tide. It's going to do the same thing with the crust. And back then, the crust wasn't broken into plates like it is today. It was just the crust. So it's stretch and compress, stretch and compress, stretch and compress. And then the heat goes into the water, the subterranean water. The water gets hotter and hotter and hotter. It wants to boil, but it can't because there's no room to boil. And at 705 degrees and 3,200 psi, it becomes supercritical water, where it's not really water and it's not really steam, but whatever it is, it dissolves things like crazy. So now it's dissolving the granite above and the mantle below, and it's mixing it all together into like limestone and silicas and quartz and cementing agents and a bunch of salts down there. And that's how you can.
What about the basalts? Basalt?
Well, now in the 8th edition, it said that it was granite, water, basalt. But now in the 9th edition, it says it's granite, water, mantle. And I'm not sure why this change was for that. But that's one of the differences in the 9th edition.
Okay.
And so then it's dissolving all this stuff, and that's how you get the carbon dioxide recirculated down there so it doesn't go up into the atmosphere. And then it gets hotter and hotter and hotter. And then and then Walt Brownie says, that it's under 372,000 PSI. Just picture all that pressure. Like if this bottle was under that much pressure and I just cracked it, it would just explode out of there and probably destroy this building. And and that's what happened. He said that the crust, it got weaker and weaker, hotter and hotter, more and more pressure. And then finally, on the 600th year of Noah's Lake, for the second month, the 17th day of the month, the same day were the fountains of the Great Deep broken up. That's when the crust cracked and the water just erupted out of there, exploded out of there almost, just shot, and then it cracked the crust. And the crust went in two directions, all the way around the world. And it came together and it went through, and it was like 3 miles a second, did the whole thing in like 2 hours. Came together, and then the water erupted out of there, and then you couldn't, and then that's how it could rain for 40 days and 40 nights.
And
And
the
people
water
said,
the water was superheated at first, right? When it come out, it was really hot.
well, yeah, it was extremely hot, but as the Joule-Thomson effect, as things expand, it cools off.
Yes.
So that's where some of the heat could get dissipated and they had a lot of expanding to do from 372,000 PSI to 14.7 on, at sea level. And so it just explodes out of there and people will say, well, wouldn't have that left a mark? And I think I might want to just share this one. And it's like, yeah, it did. It left a mark. Let's see, where did I go? Oh, I don't see. But it's the mid-oceanic ridge. And let's see here if I can find that. Try and get that for you. And it's not there. Oh, well. But the mid-oceanic, oh, there we go. Maybe, I don't know. Can you see that?
Yeah, we can see it. I see
Okay.
it.
All right. There's the mid-oceanic ridge.
Yep.
That's the 46,000 mile mountain range. And that's where that's at the bottom. That's the mantle where the water shot up. So now you've got two 60-mile cliffs. Let's see, two 60-mile cliffs, and the water's just exploding out of there, and that's where we get all our sediment. It's eroding away the granite and the mantle, and that's where we get the sediment that covers the continents. And on Earth, you can only have a cliff 5 miles high. Otherwise, it crumbles, it crushes. And this is 60 miles high, so that's all crumbling in there. It gets put off around. That's how we get the continental, the layers of sedimentary rock. And then eventually the cliff gets so far apart that there's nothing pushing down on the mantle. And then that's the mid-oceanic ridge. Mid-oceanic ridge bulges, and then the continents start sliding. So then you got, and they're sliding on supercritical water, which is it's like 50 times slipperier. It's like ice, it's like an air hockey thing. And so it's sliding. You got North America, South America sliding to the east or west, and you got Europe and Africa sliding to the east. And then they keep going till they meet resistance, and then they buckle up and form the mountains. And you'll notice that the Rockies are twice as wide as the Andes, and I think that's because it slid over the mid-oceanic ridge right there. Okay, and then that's how we get the compression. That's how we get the coal and the oil and the diamonds. Here's a folded mountain in Alberta, Canada, or British Columbia. Those folds, it had to be moist when they got compressed.
Right.
Because they're just bent, they didn't break. If that was hard over millions of years, it would have broke, and it's not. And then that's where it hit it ran out of resistance. I think it hit the mid-oceanic ridge, and then but it was still sliding at the other end, and so it just compressed. And that's how you compress granite for 50 miles. And then just to give the scale for this, those trees on the other side of this canyon, those are 15 feet tall. So this is a huge canyon. So there was a tremendous force at one time that crushed all that granite. And that's how you get it at the bottom of Grand Canyon. And then as it buckles up, it compresses, there's still layers of sediment on top of it. They keep sliding. So that's how you get slanted layers underneath flat layers in the Grand Canyon. And then that quartzite block, it got lifted up in that muddy slurry, got lifted up, and then it settled out there, and then it turned to rock, as Walt Brown's grandsons did show there. And let's see, and then you got the plateaus. How do those form? Well, mountains are a big that's a big mass on a small base, so that sinks in. So it pushes pressure on the liquid magma underneath it, and that shoots out to the side, and then it block faults the plateaus, one block at a time. So the force is gravity, and the mechanism is hydraulics. That's how you raise the plateaus. And then some of that stuff, the lava got to the top, and then when the great denudation came by for the Grand Canyon, It didn't wash away the lava on top, it washed around it, and it washed away 1,000 feet of Mesozoic sediment, and it gave us Red Butte. And you got the same thing at the other end of Grand Canyon on the eastern side by Desert View, and they call that Cedar Mountain. Same thing. That's what's left. That's what used to be everywhere before the Great Denudation to carve the Grand Canyon. Yeah, there's Red Butte. And then you got the big funnel. This is how Grand Canyon formed. That's a whole nother talk. You got two huge lakes. The key to Grand Canyon is bulging and cracking 3 times. Okay, they went through that funnel. It removed 1 or 2,000 feet of sediment. It got down to the hard Kaibab limestone. So there's nothing pushing down on it. So that bulges and cracks. Then the water from Grand Lake goes through that crack and undercuts Hopi Lake. And so now you got 2 lakes catastrophically draining or just sheet eroding everything. That's where you get the denudation, great denudation. That's 1,000 feet of sediment that's moved. And so now there's nothing pushing down on that whole area. So the Kaibab Plateau bulges and cracks. So then the water runs through the crack and it carves out the Grand Canyon. That's 800 cubic miles. And now there's nothing pushing down on the basement rock of the Grand Canyon. So that bulges and cracks. That's how you get the Grand Canyon, bulging and cracking 3 times. But you know what the mountains sinking in and the plateaus rising up, you also had the mid-oceanic ridge rising up. Well, if something rises up, something has to sink in, and that's the Pacific Ocean. And then that's why the Pacific is so much different. That's why the trenches are there. And all that volcanic activity. And who was it? Ellen McHenry, she had a class of, I don't know, grade school kids, junior high kids. She says, what does it look like at the Earth? And a kid says, it looks like somebody just punched it, the Pacific Ocean. And she said, you're right, except the force came from inside. It got sucked in. And so then the water, that's how you get the trenches. That's why it's so different. And so then even got the 8th continent sunk in, Zealandia. Buried eighth continent reveals buried secrets. They found evidence of land-based fossils there. And that's, it's New Zealand that's sticking out of it. Okay, and then the water gushes off the continents, cutting canyons in the continental shelf, and then the continents sink down and the oceans rise up and cover it with water. And that's how you get the Grand Canyon, or this canyon on Greenland. The water gushes off, and then the ice age comes and fills it up. And that's the same thing in Antarctica. By the way, they got 91 new volcanoes beneath Antarctica's ice, so maybe that has something to do with the ice sheet melting. You got to read Inconvenient Facts to get the rest of the story for that climate alarmism. Okay, but so then why didn't Alaska have a glacier during the Ice Age? Well, it's because it was closer to the shore. It's probably lower elevation, so it came down as rain instead of snow. The way you get an ice age is it snows more than it melts year after year after year. And the only way you do that is if you have warmer oceans and cooler continents. You need warm oceans to get that precipitation coming down, but you need cool continents so that it'll freeze instead of run off in the rain. And so what gives us cooler continents? Well, they were higher, therefore cooler, higher elevation. Plus, with all the volcanic activities, there's a lot more aerosols in the atmosphere, so the heat from the sun can't get to the continents. So that's how, it snows more than melts year after year after year. And at 400 or 500 years, you got the Ice Age. But during that time, the ocean is cooling off, so you're getting less precipitation, less snow, and also the atmosphere is clearing up. So now you got more heat coming to the continents. And then a couple hundred years of that, then the Ice Age is, that's how it ends. And we're still, to a certain extent, recovering from it. And as far as the mammoth, frozen standing up, some of that water from the fountains of the Great Deep was going so fast that it escaped our atmosphere and got up into outer space and got super cold. And then the gravity pulled it down on top of these mammoths. Okay. And so it froze them. So that's how cold hail is what froze them. Well, how come if they didn't thaw out? That brings us to the big roll. Okay. On a spinning mass, the northern mountains and the southern mountains in the northern mountains, or the mountains in the northern hemisphere and southern hemisphere pretty much cancel out, except for the Himalayas. There's nothing in the south to cancel out the Himalayas. And so if you got a big mass on a spinning object, that's going to try and get to the equator. And that's what happens with this. This is Brian Nicol. He put a piece of lead on that bowling ball, and that red lead is heavier than the rest of the bowling ball. So now that's trying to get to the side. Just picture that as the Himalayan mountains. So now something that's on the top where the Himalayas were, that's to the side. Therefore, something that's on the side went to the top. And that's what happened with the mammoths. They were fat and sassy, living in Mammothville, where there's lots of food and lots of water. Himalayas formed, and it brought them up to the top, where they turned into permafrost and never thawed out. And if that happened, would it leave a mark? And yeah, it did. But they find that's how you get the snakes and tortoises and alligators and badgers and shrews up in the northern. They didn't live there. That's just where they ended up after the earth rolled. And that's how you get the fossils of crocodiles, dinosaurs, and palm trees. It took tropical palm trees and brought it down to Antarctica as it rolled there. Something from the side went to the bottom. Okay, and would it leave a mark? Yeah, that left a mark. It's left the 90 East Ridge because the Earth isn't round. It's got a bulge at the equator. And as the Earth rolled through that bulge, it cracked. And that's what made the 90 East Ridge. It cracked, and that's why it's pointed pretty much directly at the Himalayas. And so my guess is the Himalayas were formed 3,100 miles farther north at one time. And then it rolled and brought the mammoths up there. And then the inland seas, oh boy, this is a whole nother topic. As the granite is buckling and fluttering as the water's shooting out and it's slamming down and shooting out and slamming down, it's going to cause electrical charges in the granite. They call it Z-pinching. The quartz in there is piezoelectric. And so that's going to cause a charge, and that can cause a bunch of neutrons to go around, and you got accelerated nuclear decay and whatever they call it. And that's going to make weak parts in the, weak parts. You can learn about that hydroplate theory thing. But quartzite is piezoelectric, and if it's in tension or if it's in compression, it makes a spark. And what if the whole continent's granite is being fluttering like that? And so how do you get the chondrules? They had to be formed in hot water. That's the subterranean water chambers. But they needed a high impact collision. This is when it slams down. When the water shoots out to the side, it slams down and then it pinches at the end. That's a high velocity collision, shoots out to the end. And then when the pressure builds up again, it shoots it up into outer space. That's how you get the chondrules in outer space. And it had to cool quickly. And that's the fluttering. And then some of it, you get some weak points in the crust, and that's just going to explode out of there. That's how you get the inland seas. That's why there's salt at the bottom of it. That salt's probably from the subterranean water chambers, and that's how you would get that. And the salt domes, walt salt can float up through denser, freshly deposited sediment, and that's what it did. You got the free neutrons and accelerated rapid decay, and it shoots up there, and some of that stuff kept on going and became our comets and asteroids. And we talked about what was already there. This is Comet 67P. It's got rounded boulders in there. See, in space, when things smash together, they're going to have jagged edges. The only way you get rounded things is if it goes through a fast flow of water before getting shot up there, and that's what we see. And then you get, how does it catch a moon? Well, they're both going in the same direction. And then Florence even has two moons. How do you get peanut-shaped asteroids? Again, they're going in the same direction from the same force and the same vector, and they come together gently. Normally they're going to, like playing pool, those balls don't stick together. They're going to fall apart. But if everything's going from the same place at the same speed, they can come together very gently, and then you can get the peanut-shaped asteroids. And let's see. And as far as the comets going in the same direction as the Earth, just imagine the Earth as a train going 100 miles an hour, and something gets thrown out at 50 miles an hour. Well, it's still going to be going pretty much the same direction as the Earth. And that's what happened. The stuff that got shot out with less velocity kept on going in the same direction as the Earth. But if, let's say, it got shot out at 150 miles an hour, now you're going to have more people going the retrograde. And that's what you see. It's a 70-30 mix. And let's say something goes out at 500 miles an hour. Now it doesn't matter which way it goes. It's going to go the other way. So now it's more of a 50-50 mix. And that's how you get Ryo. What's up with Naiku, objects weird orbit, puzzles scientists. Yeah, it puzzles them because they think of a blind chance perspective. They don't think that it could have come from the Earth. But Dr. Walt Brown's son, Robert, he teaches at the U.S. Air Force Academy at astronautics, I think he teaches. But he had a peer-reviewed paper published saying that these transnebulan objects came from the inner solar system in the rather not so distant past, or the recent past. And he was published, and so yeah, this guy says the orbit of Naiku is unusual that it's nearly perpendicular to the plane of the solar system. More than that, it's orbiting in the opposite direction of most solar system bodies. Furthermore, there are a few bodies that share the same orbital plane with orbiting prograde or some retrograde. That was unexpected. Okay, and that's why the near side of the moon is pounded. It got pounded from the fountains of the Great Deep. And the far side got protected, which is very counterintuitive. That's why the Earth's oldest rock is on the moon. That's why there's sea plankton up there. And we listened to that already. So these are all those unanswered questions, but the hydroplate theory answers them perfectly. And it's puzzling to me that a theory that makes accurate predictions has been ignored for decades. That's the question that I'd really like an answer to, because it doesn't make any sense to me.
Okay, I have my question for you is what is going on in the Drake Passage, where it looks like the flow of the continental seafloor is sort of curving around St. Georgia Island and then back towards Antarctica again. It looks like there's a little bit of a hook in it. If you pull up the map of the seafloor, you can see that.
Okay, this is the first I've heard of it. I'll have to look into that. But thank you for bringing it to the attention. And I think the theory goes that everything is trying to get back to the Pacific Ocean, like those trenches.
Hmm.
Most of the earthquakes are going in that direction, if I understand it right. And then, if plate tectonics was true, those trenches are where there's supposed to be subduction,
Hmm.
but there should be more granite there, or there should be more mass there, but there's not. There's less mass there. So what did Bob Enyart say? He said, yeah, if you want to lose weight, just weigh yourself over one of those trenches. You won't weigh as much. And
I'll have to try that.
Yeah.
But the extension goes into the Atlantic Ocean and the Drake Passage, not the Pacific. So
Yeah.
that's sort of curious to me how that. But you also said that there's a continent where New Zealand is, in Zealandia,
Yes.
and so did that sink in the whole process?
Yeah, I think that was part of the Pacific Ocean that sank, and Walt Brown, I believe he made a prediction that they'd find continental crust in the Pacific Ocean. So that's another one of his predictions, and people can check out his predictions at hpt.rsr.org or creationsciencecenter.org on page 447 to 449. I think those are the pages. There's the accurate predictions are there, or all the predictions. There's probably 50 some predictions, and 9 or 10 of them there are validated. And Fred McNabb, he's gone through and he said, no, I think there's 20 of them that have been validated. And you can see that at hydroplate.org and look under predictions. And so then we're just throwing it out there and let people think for themselves. If it's wrong, let's correct it. And if it's not wrong, let's start thinking about this theory.
So with all these plates moving around, is it possible that Greenland will become a part of the United States?
Yeah, Trump would love that. Yeah, I suppose.
So is the floor open to comments?
Sure.
Yeah.
I attended Kevin Lee's very fine presentation last week, and was happy to hear that we were going to talk about this some more, because I did a little bit of checking. Kevin Lee during his presentation said we're talking about, well, you said it was a half an ocean inside the Earth.
Yeah, and that's
Kevin
open.
Lee characterized that as 40 billion tons of water.
Yeah, and that's something that's open to discussion. Personally, I think there's more water than that. And I understand why he says half. It has to do with the deuterium, because the deuterium in the comets is twice as much as the deuterium in the oceans. And so if it's half of the ocean, then that would mean that half of it got diluted.
Okay.
But personally, I think there was more water inside.
Okay. Now, and this 40 billion tons of water is leaving the Earth at escape velocity.
Yes.
Claim. I don't know if you're aware, but a 1 kilometer diameter asteroid, which would be approximately 1 billion metric tons, is regarded as a planet killer. And since the Ark was on the Earth and had not left the Earth yet during this large ejection of water, the Ark would have been evaporated.
Well, that's assuming that it was a 1 kilometer rock that got shot up there. That's not what the hydroplate says.
Well, no, I wasn't clear.
Yeah, it's
that 1
older.
kilometer rock weighs 1 billion metric tons. And I'm sorry, Yes, 1 billion metric ton asteroid matter of mass is a planet killer. And your claim, or the claim of the hydroplate theory, is 40 billion tons. So that's 40 times the amount that would evaporate everything on the surface of the Earth, basically.
Well, most of it wouldn't even interact with the surface of the Earth. Most of it would be shot through our atmosphere in just a second. You know, it's
Then it would be a
going.
reverse. It would be a reverse entry. Basically, an asteroid explodes because it's coming into the Earth atmosphere from space. It's entering in, but having an escape velocity right at the surface of the Earth is going to cause an explosion.
It's going to cause
the same way matter entering into the atmosphere of the Earth starts to burn up. You accept that that's because of the speed of the projectile and the density of the atmosphere.
Well,
you have the same speed projectile of water entering in the densest portion of the atmosphere, that all at the same time at 40 times the amount of a single asteroid, which is regarded as an Earth-killing.
Well, maybe you're assuming that all this energy took place at an instant. This was over time. And it's like saying that, you know, you need all this, you know, so much energy to get this car to drive across, you know, across the country, you know, but it's gradual. I mean, if you had all that energy all at once, it would blow up the car, but it's over time that it gets released.
Well, even if I took that over five time constants, approximately 60%, 67% is going to leave in that first time constant. But even with that, you still have, and another way you could look at it is, say, of the 40 billion tons, 1 billion tons is released virtually instantaneously. And that's, you could expect that. 1/40th of that mass of ocean under the Earth would leave first, and that would be enough to vaporize everything on the planet.
Well, again, I think that's because you think that it's going to interact with the atmosphere. I think a lot of it is just going to shoot. There's going to be a boundary condition where a lot of this is shooting through, but it's just going to be an instant. There's going to be a boundary between the stuff that's shooting through and then the rest of the atmosphere. And again, this is hypothetical. You know, nobody really knows for sure. But I think what should be considered is the accurate predictions. If you can make accurate predictions.
How many predictions have actually been made that were accurate out of all the predictions?
I think there's like 58 of them that were made. In the book that says there's probably 12 of them. And then Fred McNabb on hydroplate.org, he thinks there's about 20 of them. But the question is, hey, how many predictions have plate tectonics made? How many of them were accurate?
Yeah, but 12 or 20 out of 58 is horrible.
Well, how does that compare with the catastrophic plate tectonics predictions? How many have they made?
Well, we're not talking about that.
Well, but we're looking at the past. I mean, because I've asked the experts. You know, the guy who made the model, asked him, what predictions have you made?
Did you ask him my question, though?
Yeah, well, we're talking about predictions. I mean, 20, that's pretty darn good, I think. It's
not in science.
Well, it's better than
58 out of 58.
Well, no. Well,
yes.
The rest of them haven't been false. They just haven't been validated yet. It's not that they were wrong. I think there was one that was wrong because of a mathematical error. But it doesn't mean just because there's 50 or 40 of them that haven't been confirmed, that doesn't mean they're wrong. But I think the big question that we should start asking is the big question I think that we should ask is, what are the predictions? You know, if people don't make predictions with their theories, Walt Brown says that they don't have confidence in it. It's weak science. And I think that the theories, everybody should start asking, you know, when you're being taught a flood model or a theory or whatever, what accurate predictions have you made? And so then we can keep score. Because right now we're up 12-0. We're up 12-0. Hydroplate is.
I'd also like to point out that there's 3 inaccurate claims that were made. First, no extraterrestrial organics have been found or been verified.
What do you mean, no extraterrestrial organics?
It means organic molecule like a bacterium or that was found that is not of Earth origin.
What has been found that hasn't been of Earth's origin?
We've had maybe 20 out of 22 amino acids, which
Right,
are very, very simple.
right. And
molecules.
I would submit that was from the Earth. Those amino
Right.
acids came
Yes,
from the
okay.
Earth.
So there
That's
has
what
not,
I
that
would say.
bacteria on the space station is from the Earth, most certainly.
Right.
And then also, this is my last comment here, and then we'll let everybody else talk. Actually, physicists are not puzzled about star formation. We have the SR and many other processes. S process was verified in 1952 by direct observation and also spectroscopy. Our process verified in 2017, direct observation and spectroscopy.
What did they observe? What did they observe?
The observation was technetium, which is atomic number 43. And they also can observe it occurring in AGB stars, large giant stars that are dying.
What did they observe? Did they observe?
They observed the element.
Did they observe a star forming?
No, they observed a element inside of a star that was present.
Right, but that doesn't explain how the star formed.
Right. So what I'm talking about is a scientific inquiry that was verified, and then obviously nobody was around to see the stars form.
Well, that doesn't explain how a star forms. That doesn't validate that we know how stars formed. We just saw an element.
But no, your claim was that we don't know how elements were formed above the iron group.
Well, in the stars, yeah. Okay. Okay,
I'll leave with that. I'll leave you with that, sir.
Okay. Yeah, because I'm just quoting their article.
Absolutely. I just want to make sure that those that I could push back on those. But that's all. I have a few more things to say, but I think I want other people to be able to talk.
Okay. Yeah. All right. So that article could be out of date. Thank you for pointing that out.
Yeah, that's all. Just want to make sure that because I'm not against this theory. This theory actually, I'm also a researcher. This theory actually helps some of my work.
Good.
So good. I'm not I just wanted to make sure that we all are armed with facts.
Yeah, I appreciate that. And this theory should be critiqued, along with CPT should be critiqued. And we're trying to get the Creation Summit. They're trying to put a flood geology summit together this year. And so we'd love to have CPT guys there. We'd love to have hydroplate people there. We'd love to.
I'm not a CPT guy or a hydroplate guy.
Right.
I have my own work that I do that is going to be leading up to explaining some of this very similar ideas.
Yeah, and that's for me, all ideas are welcome. I think every idea should be put on the table. I don't think we should exclude any ideas. And then but the interesting thing about that flood geology summit, I mean, there's one expert, he says he doesn't want anything to do with anything that gives the hydroplate any credence. Yeah. And then, and they're very biased against it. Another one actually is looking at it, and he might participate, and I hope he does. I mean, that's how science advances, is when we can look at the strengths and weaknesses of each theory. And we've been trying to get this to happen for over a year, and it hasn't happened because they don't want to step up to the microphone, or they want pre-approved questions. So I gave them a big list of questions, and they didn't want to answer them. So
Brian, what I'd like you to do is to give us maybe a list of the predictions that the hydroplate theory has fulfilled.
Okay. Well, just for sake of time, I mean, people can go into YouTube and check out the actual 9th edition. That's on page at rsr.org/HPT on page 447, I think. But this is quicker. Okay, the ones that were confirmed were they'd find pooled water under mountains. They'd find deep channels under Bosporus and Gibraltar. They'd find that asteroids are flying rock piles. They found that out with the DART mission. They'd find that rocks on asteroids and comets are rounded. They found that out with 67P. They'd find water inside large asteroids. They'd find carbon-14 in old bones. And let's see, those are the ones that those are the ones that are in this edition. I think there's some more that are in the 9th edition. But if you could also go into hydroplate.org, and then Fred McNabb, he documents 20 of them that he thinks have been confirmed. And I think the strongest argument for this theory is its accurate predictions from a variety of disciplines.
Okay, well, Brian, we appreciate you being on our TV show tonight. I think we're close to an hour in our presentation, and I want to encourage you in your effort to form this seminar. I think we're going to target September to give this presentation, and we have a number of different people who are experts in geology giving these presentations. And so I'm going to participate with my geology theology book, and I think it's a good chance for us to get to know each other and to bounce these ideas off of each other, because we weren't there when it happened. We can only speculate, and we can test our models against what we know from science, but it is not an exact science because we can't control any of the experiments.
Right. Right. And I would just encourage people to look at at the beginning, all those unanswered questions, all those puzzled scientists, all those things could be answered with the hydroplate theory if it's allowed to be discussed. And as creationists, I think we should set the stage. We should lead by letting theories be discussed. I mean, that's how science works.
So we'll see you next time on Revolution Against Evolution. Thank you for joining us. Don't let your geology mess up your theology. Sedimentary rock covers the continents at an average depth of 1.5 miles. Was that a gradual buildup over millions of years, or a year-long catastrophe like Noah's flood? Here's an evolutionary geologic column found only in textbooks. It's built by correlation. Does it represent reality? This column shows mostly vertebrates. That's skewed. But 95% of the fossils are invertebrates. 4.5% is plants and algae. Just a very small percentage of fossils are vertebrates. 95% of that is fish. But what if you find topsy-turvy fossils? Topsy fossils are supposed to be down, yet they're found up. Turvy fossils are supposed to be up, yet they're found down. I'll show a few examples. In Glacier National Park, here at Gunsight Mountain, the top layer is Precambrian. Underneath is Cretaceous. The entire park is upside down. At Tube Medicine, it is at the eastern end of the 50-mile out-of-order sequence. How could a section of mountains 350 miles long be uplifted and shoved over 50 miles? 25 miles west of Las Vegas, Nevada, in Red Rock Canyon, the rock sequence is Cambrian on top, then Jurassic, Triassic, and Permian. The gray rock is Cambrian and the red rock is Jurassic. 75 miles to the north and east is the Valley of Fire. That out-of-order sequence is the same, Cambrian, Jurassic, Triassic, Permian. In the middle is Precambrian Frenchman Mountain. Were there two overthrusts, one that created Red Rock Canyon, the other the Valley of Fire? Or was there one massive overthrust creating both? Or was this a Noah's flood event? South of Tucson, the Empire Mountains are Permian on top, then Cretaceous. But the contact is wavy, meshed like a gear. These and many other examples show that something is greatly wrong with the geology that we have been taught in public school.